write the first four non-zero terms of the Maclaurin series for e to the x. Use the Maclaurin series for e to the x to write the third degree Taylor polynomial for g to the x is equal to e to the x times f of x about x equals 0. So Maclaurin series, if that looks familiar to you, watch the videos on Khan Academy on Maclaurin series. I'll give a little bit of a primer here. If we're taking the Maclaurin series of f of x, that's going to be equal to f of 0. We could view it as f of 0 times x to the 0 over 0 factorial, if you assume 0 factorial is equal to 1, and then plus f prime of 0 times x to the first over 1 factorial, plus f prime, the second derivative evaluated at 0, times x squared over 2 factorial, I think you see the pattern here, plus f prime, the third derivative evaluated at 0 of x to the third power over 3 factorial. I think you see where this is going. And of course, this first one, x to the 0 over 0 factorial, that's just 1. So oftentimes it'll just be written f of 0. And this term, 1 factorial, is just 1. So oftentimes we'll just see it written as f prime of 0 times x, so on and so forth. So, and actually, let me just write approximately right over there. And so let's do it for e to the x. So e to the x is approximately equal to, well, it's going to be e to the 0, which is 1, plus, you might already know that f of x, if f of x is equal to e to the x, then f prime of x is also equal to e to the x. That's one of the magical things about e to the x. The slope of the tangent line at any point is, well, equal to the value, is equal to the x value there. And if you take the third derivative, or second derivative, it's also, you can take as many derivatives as you want, you still get e to the x. That's one of the special things about e. So the first derivative evaluated 0, well, that's still e to the 0 power times x to the first. So plus x. And then we have the second derivative evaluated at 0. Well, that's still 1, so it's going to be times, or so it's 1 times x squared over 2 factorial. So we could say plus x squared over 2, plus x squared over 2. 2 factorial is just 2 times 1. And then plus, once again, the third derivative evaluated at 0. That's just e to the x evaluated at 0, which is e to the 0, which is 1. So x to the third over 3 factorial. So plus x to the third over 3 factorial. We could write it as 3 factorial, or that's 3 times 2 times 1. That's equal to 6. And then we keep going. So we just wrote the first 4 non-zero terms of the Maclaurin series for e to the x. That's 1, 2, 3, 4 non-zero terms. Now we want to use, so let me just underline that. That's part of what they're asking us to do. Then they say, use the Maclaurin series for e to the x to write the third degree Taylor polynomial for g of x, which is equal to the product of e to the x and f of x. So what I'm going to do is I'm going to write our original f of x. Let's write down the first few terms of it. And then what we could do is think about, well, how can we multiply those two polynomials? And we just have to know enough about the multiplication of those two polynomials to just get us our terms that are no higher than third degree. So f of x is approximately equal to, let's see, it's x, I have a bad memory, it is x minus 3 halves x squared, x minus 3 halves x squared, and then plus 3x to the third power, plus 3x to the third power, plus 3x to the third power, plus, and or actually you could say minus if you like, because then it's going to be, you're going to have, it's plus, minus, however you want to do it. And that's enough. And why do I feel confident that it's enough? Well, we only want to write the third degree Taylor polynomial. So if we multiply these and we involve terms that are higher than third degree, well, that's going to give us the terms in our polynomial that are higher than third degree. So let's just think about it. What's going to be the product? So e to the x times f of x, that's going to be approximately equal to, well, let's see. We are going to multiply this infinite polynomial times this infinite polynomial, and that might seem intimidating to you at first, but what you could do is you could go for each of these terms, start multiplying it times each of these terms out here. Essentially, when you're multiplying polynomials, you're just repeatedly doing the distributive property. So you take this and distribute it onto that. but we should only worry about the terms up to third degree, because anything beyond that, well, that's going to add up to a higher than third degree term. So x times 1 is x times x squared, or sorry, x times x is x squared, so plus x squared. X times x squared over 2 is x to the third over 2. So I'll just write plus 1/2 x to the third power. And I'm going to stop there, because if I do x times that, that's going to be a fourth degree term. And I don't want to worry about that. We are writing the third degree Taylor polynomial. So that's x squared, x to the third over 2. So now let's distribute the negative 3/2 x squared. And I'll use another color here just to help explain it a little bit. So if you multiply that times 1, that's going to be minus 3/2 x squared. I'm just going to a second line here so I can line things up and add them nicely. And then this times this is negative 3/2 x to the third, negative 3/2 x to the third. And once again, I'm going to stop there. If I multiply these two, I'm going to get a fourth degree term, and I don't care about the fourth degree terms. And then let's worry about this guy. And so let's start distributing. So if I multiply it times this 1, I'm going to get 3x to the third power, 3x to the third power. And I'm going to stop there, because then if I start multiplying it times that guy, that's going to be a fourth degree term, and then a fifth degree term, and then a sixth degree term, which I don't need to worry about. So these are all of the pieces that are going to make up that third degree polynomial. And so what is that going to be equal to? What is that going to be equal to? And this was a little bit of, getting your math intuition for multiplying infinite polynomials. Let's see, you're going to have x, and then you're going to have, this is 1x squared minus 1.5 x squared. So that's going to be negative 1/2 x squared. And let's see, here you have plus 1/2 minus 1.5, which would give you negative 2, and then plus 3, 1/2 minus 1.5, which would be negative 1, plus 3 is positive 2, plus 2x to the third power. So we could say e to the x times f of x, the third degree Taylor polynomial for this, is x minus 1/2 x squared plus 2x to the third power. And we are done. So this was a little bit tricky. You had to appreciate how to, but it's not calculus. It's a little bit of just algebra of just appreciating, okay, I only need a third degree. I don't have to distribute this times an infinite number of terms. And because at first you might say, well, that's super hard. How do I multiply two infinite polynomials? The key is we only worry about the third degree, up to the third degree.